Hello viewers, I am Kausalya. Today we are going to solve gate questions related to Bode plot and signal flow graph. The first problem is the Bode plot of a transfer function g of s is shown in the figure below. Find the transfer function. Right. So here this is the plot which is given as a problem. Right. So here in this case we have to just go in the reverse procedure. So normally the transfer function will be given, then we will be drawing our Bode plot. But here the Bode plot is given and we are asked to find the transfer function. Right. So here the first thing is, at omega is 10, right? That is when omega is equal to 10 radian per second, the respective magnitude is minus 8. Right. Similarly, when the value of omega is 1, actually it has to be like this, right? So when it is 1, the magnitude is equal to 32 dB. Right. So first make a note of it. That is, you see, when omega 1 is equal to 1 radian per second, the respective magnitude is 32 dB. How will you represent magnitude? In terms of 20 log something, right? So here I had written it as 20 log G1. And again at omega 2, when omega 2 is equal to 10 radian per second, what about the magnitude? It is minus 8 dB. So here it is minus 8 dB, right? Now we are proceeding with the formula for slope. So slope is given as 20 log G2 minus 20 log G1 divided by log of omega 2 minus log of omega 1, right? So here again when you substitute the values, we know the values of 20 log G2 as well as 20 log G1 and omega 1 and omega 2. So just substitute the values here. Once you substitute the values, here the value of the slope is, it is minus 40 decibel per decade, right? So here, whenever we are having minus 40, what does it represent? We are having an S term in the denominator, not an S term, because here if we have minus 20, it denotes that there is an S term in the denominator. In case if it is minus 40, then there is an S square term in the denominator, right? Therefore, the transfer function should be of the format k by S square, right? Because here we are having the slope as minus 40, right? Now, the next step is we have to calculate the value of k. So, how to calculate the value of k? You see, again, we are considering the magnitude, right? So magnitude is generally represented as 20 log g of j omega in decibels, right? So here what is the transfer function? The transfer function is k by s square, right? So in the place of s, we have to substitute the value of omega, right? So we know two values of omega, but initially we are considering the value of omega as 1, you see. Here we have two values of omega, right? Omega equal to 1 and omega equal to 10. Now here I am considering omega value as 1 here. So I am taking this thing, okay? At omega equal to 1, the magnitude is 32 dB. So here 20 log k by 1, right? So what is the magnitude when omega equal to 1? It is equal to 32 decibels, right? Now you see 32 is equal to 20 log k. I am solving this expression. So when you solve this expression, the value of k is calculated as 39.81, right? So while writing the transfer function, you see it is k by s square. The value of k is 39.81, right? So just substitute it over here and finally this is the transfer function for the given Bode plot, right? So here comes the end of this problem. We will move to the next one. The second problem is the signal flow graph for a system is given below. The transfer function for the system is, right? So the signal flow graph is given and we have to calculate the transfer function, right? So you see, as usual, we have to proceed with the steps. So we have to calculate the forward path gain. So what is the forward path? What are all the number of forward paths available here? You see, this is our first forward path and this is our second forward path, Okay, there are no more forward paths because these two arrows are in reverse direction, right? So in this forward path, what are all the gain values? They are s to the 1 into s to the power minus 1 into s to the power minus 1 into 1. So what happens? That becomes s to the power minus 2, right? And when you go for the second forward path, okay, this is your second forward path. So 1 into s to the power minus 1 into 1 into 1. So that gives s to the power minus 1. Right. Then the next step is we have to look for the loop gains. So here we have to calculate how many loops are there in total. So as we all know, a loop is nothing but whose starting and ending node should be the same. So here you see, this is one loop, right? And again, this is your another loop. So first we will write respective loop gains then and there, right? So this is your loop. What will be the loop gain? Minus 4 into s to the power minus 1 will be the loop gain. This is what I had written, right? Again, now consider this loop. So 1 into minus 4, that gives you an answer of minus 4 here. And the next thing is, you see, we are considering the loop like this, that is this and this. Okay, so s to the power minus 1 into s to the power minus 1 into minus 2. So that gives minus 2 into s to the power minus 2. And the next thing is, as usual, you see, this. So s to the power minus 1 into 1 into minus 2. So that gives the answer as minus 2 into s to the power minus 1. Right. The next thing is we have to find the non-touching loops also. So but here comparatively there are no non-touching loops, right? Because one loop is this and another loop is this, and again the third loop is like this and fourth loop is like this. Almost they are always they tend to share some common nodes. So there are no non-touching loops in the first path as well as the second path also. Therefore the value of del 1 and del 2 is equal to 1 here. The next thing is, as usual, we have to calculate the delta. So delta is given by 1 minus sum of individual loop gain plus sum of gain product of two non-touching loops, right? So 1 minus sum of individual loop gain. Here we are having 4 loop gains, right? These 4. So just substitute it here. And finally, we had got the value of delta like this, right? Then how to write the transfer function? So the transfer function is given as, okay, given by this formula. P1 del 1 plus P2 del 2 divided by del here. So P1 del 1, okay, we know the value of P1, we know del 1. Similarly, P2 and del 2, just substitute the values. Okay, after substituting, you see, we are having a transfer function like this. Still, I want the transfer function to be modified. So here, we are dividing both the numerator and denominator by s to the power minus 2. So when you divide, you see, it gets simplified as, you see, these two will cancel each other, and here there will be an s to the power minus 1 in the denominator. Therefore, 1 plus 1 by s to the power minus 1 divided by, and here this s to the power minus 2, okay, when you move it to the numerator, that becomes s square. Similarly, here this s to the power minus 1 and minus 2, that is 1 s will cancel. So the remaining term is 6 by s to the power minus 1 plus, and here the 2 cancel. So simply we will be having 2, right? So again, when you move this s to the power minus 1 to the numerator, that becomes 6s, right? So the final transfer function is 1 plus s divided by 5s square plus 6s plus 2, right? This is the transfer function for the given signal flow graph. Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.